In this tutorial, we're going to look at how to calculate the Mann-Whitney U test for the OCR Psychology specification. The formula used is different to the Edexcel or AQA Psychology specifications and is different to the formula used on past OCR exam papers. The Mann-Whitney U test is a statistical test that can be used to see if there is a significant difference between groups. A Mann-Whitney U test is used when you have an independent measures design. This means that there are different participants in each group, i.e. you have separate groups. In order to carry out a Mann-Whitney U test, you also need to have ordinal data. Ordinal data is numerical data which can be put into an order. However, the differences between the numbers are meaningless or difficult to determine. For example, you might ask people to rate a therapy out of 10. This means their ratings can be ranked in order. But it is difficult to determine the difference between a person giving 9 out of 10 versus 8 out of 10. The Mann-Whitney U test can also be used when you have interval data. That's data along a linear scale with intervals between the data points. Let's look at an example of when we might use a Mann-Whitney U test. A researcher might ask two groups of schizophrenic patients receiving different therapies to rate their treatment out of 10. There are two conditions, with each participant taking part in only one of the conditions. So it is an independent measures design. The data are ratings, which is ordinal data, and so the Mann-Whitney U test is appropriate. A Mann-Whitney U test requires all the scores to be ranked together, as if they came from one group. Look at Group A in the table. Notice how participant 3 and 5 in Group A both ranked Therapy A as 2 out of 10. This is the lowest rating for both Therapy A and Therapy B. If participants have the same score, they are given the same rank. Now look at Group B. Notice how participant 4 in Group B has rated Therapy B as 10 out of 10. This is the highest rating. This score needs to be given the highest rank out of the 12 scores altogether. Let's now try to rank the data. The Mann-Whitney U test requires all the scores to be ranked as if they came from one group. So let's put all the therapy ratings in order from lowest to highest. So we will have all the ratings for Therapy A and all the ratings for Therapy B put together. And so we have 2, 2, 3, 4, 5, 5, 6, 6, 7, 8, 9, and 10. Now we need to give all the ratings a rank. First, let's give each rating a rank as if all the numbers were different. Look at row 2 in the table. There are 12 numbers, so I've ranked them 1 to 12 to start with. However, when there are two ratings that are the same, they must be given the same rank. Look at row 3 in the table. As the first two numbers are the same, instead of being given rank 1 and 2, they are both given the rank 1.5. Because 1 plus 2 divided by 2 equals 1.5. So the mean or the average rank for the first two numbers is 1.5. 3 stays as a 3 because there's only one 3. The 4 stays as rank 4 because there's only one 4. Then we have two 5s. They would be normally in position rank 5 and rank 6. But because they have the same rating, we need to give an average of that. So that's 5 plus 6 divided by 2, which equals 5.5. So they're both given the rank of 5.5. Because when we have two of the same ratings or scores, we have to give them the same rank. And that's the same with the two 6s. They would normally occupy rank 7 and 8, but we need to give them the average of that, which is 7.5 and 7.5. The 7 stays in rank 9 position, the 8 ranks 10, the 9, 11, and the 10 in 12th place in terms of ranking. This table shows how the two different groups have been ranked together. So next to therapy A, participant 1, who was receiving therapy A, ranked it 3 out of 10. And that is in rank position 3. The second patient ranked therapy A as 4 out of 10, and that ranks as 4. And so all the ranks have been put next to the ratings here. These are the ranks for group A. And then therapy B, patient 1 in group B rated therapy B as 9 out of 10, and that rank is 11. The second patient in group B gave therapy B a rating of 7 out of 10, and this becomes rank 9. So the last column in the table shows the ranks for group B, who received therapy B. Here is the formula for the Mann-Whitney U test. U1 refers to group 1, and R1 refers to the total of the ranks for group 1. U2 refers to group 2, and R2 in the formula refers to the total of the ranks for group 2. Let's look at our data again. You need to add up the ranks for group 1 and the ranks for group 2. R1 is the sum of the ranks for group A's data. So 3 plus 4 plus 1.5 plus 7.5 plus 1.5 plus 5.5 equals 23. And R1 is the sum of that group 1 or group A's data. Then 11 plus 9 plus 5.5 plus 12 plus 7.5 plus 10 equals 55. It gives us the sum of the ranks for group B's data, who are receiving therapy B. Let's look at the Mann-Whitney U formula again. The N in the formula relates to the number of participants. N1 is the number of participants in group 1. N2 is the number of participants in group 2. And just to remind us, R1 is the sum of the ranks for group 1's data, and R2 is the sum of the ranks for group 2's data. Now let's calculate U1. Step 1, calculate U1 by first adding up all the ranks of therapy A. To calculate, R1 equals 3 plus 4 plus 1.5 plus 7.5 plus 1.5 plus 5.5 equals 23. Step 2, calculate N1 times N1 plus 1. So let's do the bit in brackets first. N1 plus 1, well, N1 is 6 because there are 6 participants in group 1, or those receiving therapy A. So N1 is 6, so N1 plus 1 is 6 plus 1, which equals 7. As N1 plus 1 equals 7, and N1 equals 6, well then N1, which is 6, times N1 plus 1, which is 7, well, 6 times 7 equals 42. Step 3, calculate N1 times N1 plus 1 divided by 2. That's going to be 42 divided by 2, which equals 21. Then finally, we're calculating U1. U1 is R1 minus N1 times N1 plus 1 divided by 2. As we know, N1 times N1 plus 1 divided by 2 equals 21. And R1 is 23, so U1 is just going to be 23 minus 21 equals 2. Now let's calculate U2. R2 is the sum of the ranks for therapy B, which is 11 plus 9 plus 5.5 plus 12 plus 7.5 plus 10 equals 55. Then we have to calculate N2 times N2 plus 1. Now, N2 is the number of participants in group 2 receiving therapy B. And there were 6 participants again receiving therapy B. So N2 is 6. So N2 plus 1 is 6 plus 1, which equals 7. As N2 plus 1 equals 7 and N2 equals 6, then N2 times N2 plus 1 is going to just be 6 times 7 again, which equals 42. And then if we look at the formula, we have to do divided by 2. So N2 times N2 plus 1 divided by 2 equals 42 divided by 2, which equals 21. As they're the same number of participants in group 1 and group 2, this will be the same as when we calculated U1. So the N2 times N2 plus 1 divided by 2 ends up being the same. So how do we calculate U2? Well, it's just going to be R1 minus N2, so it's R2, for U2 it's R2, which is 55, minus N2 times N2 plus 1 divided by 2, which is 21. That's going to be 55 minus 21, which equals 34. So what is the value of U? The final calculated value for the Mann-Whitney U test is the smaller of U1 and U2. So as U1 is the smallest value, U1 is the value of U. Therefore, U equals 2. Once we have the observed or calculated value for U, we need to compare it to a critical value. Critical values are numerical values which researchers use to determine whether or not that their observed calculated value from a statistical test is significant. Psychologists prefer to use the significance level P is less than or equal to 0.05 to judge whether to accept a hypothesis or not, because it means that there's an equal or less than 5% probability that the results are due to chance. So if the researcher was going to carry out the research on a different day or different participants, they would expect that they're very likely to get the same results, and there's only an equal or less than 5% probability that they would get different results. Therefore, you need to look at a Mann-Whitney critical values table for P is less than or equal to 0.05, the 5% significance level. Compare the calculated value of U with the critical value. In this critical values table, look up the critical value for N1 equals 6 and N2 equals 6, because we had 6 participants in group 1 and 6 participants in group 2. If you look at the red arrows, so for N1 is 6, and then for N2 is 6, the critical value is 5. Compare the critical value with your calculated value of U. For Mann-Whitney U test, U has to be equal to or less than the critical value for the result to be significant. The critical value for two-tailed test at 0.05 significance level equals 5. As U equals 2, this is less than the critical value of U at the 0.05 significance level. This means that there is a significant difference between therapy A and therapy B. Now let's try this multiple choice quiz. There are 5 questions. So question 1, for Mann-Whitney U test, is data ranked together or separately? A, together, or B, separately? Pause here if you need more time to think about this question. The answer is A. Data is ranked together for Mann-Whitney U test. Question 2. In the Mann-Whitney U formula, what does R1 mean? A, the number of participants in group 1. B, the sum of the ranks for group 1's data. C, the sum of the ranks for group 2's data. Pause here if you need more time to think. And the answer is B. R1 is the sum of the ranks for group 1. Question 3. In the Mann-Whitney U formula, what does N1 mean? A, the sum of the ranks of group 1. B, the number of participants in group 1. Or C, the number of participants in group 2. And the answer is B. N1 is the number of participants in group 1. Question 4. Is U the higher or lower of U1 and U2? A, higher. B, lower. And the answer is B. U is the lower value of U1 and U2. And last question, question 5. Does the observed value need to be bigger than or smaller than the critical value for the result to be significant for Mann-Whitney U test? A, bigger than, or B, less than? And the answer is B. The observed value must be smaller than the critical value for the result to be significant for Mann-Whitney U test.